Hello students. In the last videos we had seen about the binomial distribution as well as Poisson distribution, and we had seen they were the discrete kind of distributions. Okay. Now we are moving to the normal distribution, which I had explained in the brief already. Okay. And I had also said that this normal distribution is a continuous distribution. Okay. This is the only change which it has as per the binomial as well as the Poisson. Okay, this is what makes this normal distribution different, that it is continuous. Okay, and now see the normal distribution, that means what, the thing which occurs normally into the universe, right? So we have it, this bell shaped curve. Okay, now even this is a normal distribution, or this is also a normal distribution. This is also a normal distribution. I had explained this, that only the frequency is changing. That is what I had explained about skewness and kurtosis, which measures one is that the frequency difference between the two curves, or the way it has been shifted. Now, if I go to say this is also a normal distribution curve, okay, but this is quite different from this. That is what its mean value has been shifted. Now, let me draw this part again. Now, if I have this frequency distribution curve, okay, now this peak level, at this peak level of the probability or the frequency, I have my mean value. Okay, it is x bar for a sample, for sample. Okay, or for population it will be what, mu. Okay, now see, what is assumed is the area covered by this curve. See, this curve is not touching to this line. Okay, but it is somewhere, it is going very close to it, but it is not touching the line. Okay, so it is assumed that the area covered by this curve is 1 unit. Okay, and it has been assumed that zero point 0.5, that is half of the area of that one, lies on this right side of the curve, and half of the area lies between left side. Okay, that is 0.5 of the area lies in this positive section, and zero point 0.5 area lies in this negative section. Okay, that is together it comes out to be the 1 unit area. Okay, now also it has been mentioned, now we have seen something called as standard deviation. Standard deviation, that is S for sample and sigma for the population. Now it has been mentioned that, see, standard deviation, the use of standard deviation is what? It is like x bar plus or minus that standard deviation value has been accepted. Okay, that is x bar plus or minus s, suppose. Okay, so now if the standard deviation is s, okay, then I can have it as, that is x bar plus s is here, x bar plus s, this will be x bar plus s. Okay, so this one will be the area between x bar plus s. Okay, similarly this one will be x bar minus s, that is this area will lie between x bar minus s area, right? So it is assumed that when the standard deviation is s, this together area from this point to this point, that is this part entirely, covers 0 covers 68.27% of the entire curve. Okay, this one will have the major part, that is 68.27% of the entire curve. Now, similarly, if we go more further, that is if I draw this again, okay, the same bell shaped curve with mean here x bar. Okay, and I have drawn, this one is my s value, that is x bar plus s, and suppose I draw it again, that is x bar plus 2s. Okay, similarly on this side, x bar minus s, x bar minus 2s. Okay, then this total area between this x bar 2s, x till x bar plus 2s, this total area is said to be covering 95.45% of the entire area. Okay, and if that this standard deviation is being added one more times, that is third time, then it will be something like this. Okay, this curve mean here, then here 1s, 2s, somewhere here it will be, sorry, this is not touching it, 3s here, and somewhere the 3s here. So then whatever this area will be between x bar minus 3s till x bar plus 3s, this area will be covering my 99.73% of the total area. Okay, so only 0.3% area remains after this. Okay, so we normally say that the total area of this curve lies between x bar minus 3s till x bar plus 3s region. Okay, that is x bar plus or minus 3s region. Therefore, this 3 has a very important value in this our normal distribution. Okay, that is what we see say that this entire curve has been divided, or this entire distribution, normal distribution, has been divided into these three parts. That is, first part is this x bar plus or minus 1s, then second one, this one, s bar plus or minus 2s, and the third one, s bar x bar plus or minus 3s. Okay, and most of the area has been divided into, most of the probability distribution lies within that x bar plus or minus 3s, where s is the standard deviation. Okay, so now if at any point I have the value, let me just draw this again. Suppose I have x bar here, and if I have some x value here, okay, which will I see? Then the any area lying between this I need to find. Then it will be what? 0.5. This total area is 0.5 minus this area. Okay, whatever area greater than x. Okay, this is how we represent it, or we can even represent this the way we want, the way the question has been framed. We can reframe our formulas. Okay, if I want this area and here it is my x bar and here is x, then I can write this as, this area can be 0.5 minus the area lying between x bar and x. Okay, that is this total 0.5 minus this area will give me this area. Okay, so the in this way the question can be reframed on based on the whatever data we have. Okay, or we will understand this with the example. See, before that we'll just see this normal distribution formula. Okay, the it is given by z is equals to x minus x bar upon s. Okay, now what is this z? Now this z is, as I said, this number of standard deviations. Now, how many standard deviations I said this curve is divided into? 3. Okay, so that is what my value for z must lie between minus 3 to 3. Okay, so this has, I had said that these three has a very important value in this normal distribution. That is because of this my z value should lie between minus 3 to 3. Okay, so that is the number of standard deviations. Okay, when once I know the number of standard deviation, Now see, suppose my z value is equals to 3. Okay, that means what? My curve is lying somewhere here. Okay, the required point is somewhere here. Okay, and if I want to find any area less than this z is equals to 3, then my area will be total of this region. Okay, now my area lying between x bar and this z will be z is equals to 3 will be given by this area. Okay, and what will be the value of z, or the probability distribution at this, will be given in the table, as we have given the table for the freedom, degree of freedom, which we had found last time. Okay, I had given one table. So similar kind of table is there for finding the area under the curve for this set. Okay, or the probability distribution for this set. But most probably in the exam, the tabulated value will be given directly. Okay, we'll see how the question is framed in these cases. Okay. Okay, so first is this z is the number of standard deviations, and we know that this value should lie between -3 to 3. Okay, now it may sometimes crosses this 3 value because of some human error, and that is accepted at some places. Okay, this x is the value which we need to calculate, or which will at which we need to calculate the probability. X bar is the mean. Okay, x bar is equals to mean of the sample, and s is the standard deviation of the sample. Now this formula is for the sample. Now if I want to reframe the same formula for a population, how it will be? Z is equals to x minus, now for the population the mean value is given by mu, divided by the standard deviation value is represented by sigma. Okay, when such a formula is there, it is understood that it is for the population. Now let's see how to solve this question. Okay, what it is, let's see this first example. In a training program, the director has recorded from the study of past participants that the mean length of the time spent on the program is 500 hours. Mean length is 500 hours. So it is directly understood that this x bar is equals to 500 hours with a standard deviation of 100 hours. So it has been directly given that the standard deviation s is equals to 100 hours. What is the probability that a candidate selected will take between 500 to 610 hours to complete the training program? Okay, now this question is of normal distribution. Now it has been nowhere mentioned in this question that it is a normal distribution question, but normally it will be mentioned in the exams. Okay, since we are doing the problems of this part only, I have chosen such example where it is not mentioned. Okay, now first thing I need to find out whether this 500 hours is mean of the sample or of the population, and it should be written as x bar, or the standard deviation should be written as s or sigma. Okay, that is, this is for the this entire data given is for the sample or the population. So now let's see what it is given, that this has been recorded from the study of past participants. That is what it has been taken from the sample. This past participants were my sample. Okay, so now it is x bar is equals to 500, s is equals to 100 hours, and now what I need to calculate, that what is the probability that it will take a candidate 500 to 610. This 500 is my x bar, and now this 610 will be my x value. So x is equals to 610 hours. Now all the data is with lying within hours, the units are same, so there is no need of conversions. Now if any of this data was within minutes or days, we need to convert it. Okay, now this issue is solved here. Okay, so now the next thing is that putting this within the formula. So what is my formula? Z is given by x minus x bar upon s. Now for this it is what x is what 610 minus x bar is 500 and s is given by 100. Okay, so now this value is giving 110 upon 100 and this gives me 1.1 as the value 1.10, I would say, to be more precise. Okay, now z value I has found. Now z means what? Z is the number of standard deviations. Okay, now let me put this in the graph. Let me draw this graph. There is no need of drawing the graph each and every time, but it will be safer so that your examiner cannot cancel your marks. Okay, so now in this case the normal distribution has been drawn. Now my mean was said to be 500. Okay, now next is it was said that x value is 610. Now 610 is greater than 500, that means it will lie somewhere at the right hand side. Okay, so let's say it lying here, that is 610. Okay, and the question is what is the probability that a candidate selected will take between 500 to 610 hours, okay, to complete the training program? That means what? The area between 500 to 610 should be calculated. That is which area? The area lying between this 500 to 610. Okay, now this area will be given how? For finding the value of this area, okay, you need to make use of z is equals to 1.10, which we have calculated. Okay, and either this value will be directly given or you need to check this from the table. Now, how to check this from the table? See, in the table it will be given. Here the Z values will be listed 0.1, 0.2, 0.3, 0.4. Like this, it will be listed 1.1, sorry, 1.0, 1.1, 1.2, like this, till what? 3.0. As I had said, Z value lies between 1 to, sorry, 0 to 3.0. Sorry, it will start from 0.0. Sorry for this. So all your values will lie between this. Z values will be like this, and correspondingly there will be the areas. Okay, that is 1.1. For this you will have to look at this table. It is 1.10, therefore the first table you will see. Okay, the first value here. So and that value is 0.3643. Okay, again this value whatever you will look will be less than 1. Okay, why? Because the total area of the curve is 1, therefore this value whatever you are finding, this area will be less than 1. So in this case it is, this total area is 0.3643. Therefore, what it is, the probability that a person or a candidate will take a time between 500 to 610 to complete the program is is 0.3643. Okay, so this is your final answer. Now let's see one more example. The life expectancy of a bulb whose lifetimes are normally distributed. See, this word normally distributed tells you that you have to use this formula. Z is equals to x minus x bar upon s. Sorry, sorry for this, x bar upon s. Okay, with a mean life of 750 hours. A mean life of 750 hours, that means x bar is equals to 750 hours. And a standard deviation of 80 hours. That means s is equals to 80. What is the probability that a light bulb will last 850 hours? Okay, you need to calculate the probability that it will be lasting 850 hours. That means what you need to calculate? You need to calculate x is equal for x is equals to 850. You need to see the things. Okay, so now if I put these values in this formula, it will be what? Z is equals to x is your 850 minus x bar is your 750 divided by your s value, that is 80, and this comes out to be 850 minus 750, 100 divided by 80, and this comes out to be 10 by 8, that is 1.25 around. Okay, and what it is given, the tabulated value for this is 0.3944. So it is what? It is quite direct that the probability of this lying between of the light of the probability of the light bulb life will be 1.3944. So probability is 0.3944. Okay, that is what graphically how it will look. Here will be your 750, and here somewhere it will be 850, and you need to calculate this area. Okay, so this is how your problems will be solved. I'll solve more problems of all these three types of these probability distributions in one more video. Okay, so that you will understand how to differentiate between these problems.